Okay, in this week's module, we're going to be looking at some conservation laws. Now, a conservation law is a very, very powerful tool in physics and in the physical sciences. And basically, what a conservation law tells you is it's a rule. And it's a rule that tells you how things are allowed to change and when they're not allowed to change. So by understanding the rules that explain how things are allowed to change or not change, we can make predictions. We can, based on things that we know, we can predict what must happen in the future because we know how those things are allowed to change. In this week's module, we're going to look at two particular conservation laws. We're going to be looking at conservation of mass, which is sort of our simple example that we'll use to explain what a conservation law is. And then we'll look at conservation of momentum, which is a much more complicated conservation law, but it's the one that's going to be of particular interest to us in this lab. Now, if you read the document in the module, you saw that we did some examples explaining conservation of momentum, but they were pretty complicated, and so that's what I want to make the subject of this video. I want to go through the examples in the course document sort of step by step to help you follow along. Okay, the first example that we looked at was what happens if you have a 3-kilogram gun firing a 0.025 kilogram bullet, that's a 25-gram bullet, with a speed of 150 meters per second. So the question is, what velocity does the gun kick back with? And so we can solve this problem by using our conservation of momentum law. Now let's remember that momentum is defined as mass times velocity, and for some strange reason it's usually represented by the letter P. So here we have the momentum, which is represented by P, is equal to the mass times the velocity. That's the rule. And our conservation of momentum law tells us that the momentum before has to equal the momentum after. So let's ask the question, what's the momentum of our system, the gun and the bullet? What's the momentum before I pull the trigger? Well, neither the gun nor the bullet are moving. They both have a velocity of equal to 0. And so that tells us that the momentum before the gun is fired is equal to 0. So we know the momentum before is 0. We can now ask, what's going to be the momentum of the gun and the bullet after? And so we can say the momentum of the bullet is going to be the mass of the bullet, which is going to be a very tiny thing, times the velocity of the bullet, which is going to be big. So I've written them with a small m and a big V. That's the momentum of the bullet. And so we have the momentum of the bullet, and we're going to need to add to that the momentum of the gun. And so I'm going to write that as a big M times a little v, because we know that the mass of the gun is significantly larger. The mass of the gun is bigger than the mass of the bullet. So I've chosen to represent the mass of the bullet with a small m and the mass of the gun with a big M. And then the velocities are kind of backwards to that. The velocity of the bullet is big, so I've represented it with a big V, and the velocity of the gun is going to be relatively small, and I've represented it with a small v. And so this is the momentum of the bullet over here, and this is going to be the momentum of the gun. So these two together, the momentum of the bullet plus the momentum of the gun, that's going to be the total momentum after the collision. So, or I'm sorry, after the gun is fired. So this is the total momentum. So now we can say that those are equal. So we have the momentum after, which is going to be the mass of the bullet times the velocity of the bullet plus the mass of the gun times the velocity of the gun. That's the momentum after. It's got to be equal to 0 because that was the momentum before. The momentum before has to equal the momentum after. And what we're looking for is this guy here. We want to find the velocity of the gun after the bullet is fired. And so we know the mass of the gun, we know the mass of the bullet, and we know the velocity of the bullet, so we can do some algebra and solve for this little v. So what I can do is I know that I can subtract this term from both sides, and what I'll end up with is m times little v is equal to minus little m times big V. So I just took this guy here and brought him over on the other side of the equal sign so that I could solve for this v here. Now finally I want to divide both sides by this capital M, and that will get me little v by itself. So we have little v is going to be minus little m times big V divided by big M. And when we plug in the numbers, we get that this is going to be equal to, so we have, again, sorry, I'm on another slide here. We have little v here, which is what we're trying to solve for. That's the velocity of the gun after we pull the trigger. It's equal to minus m big V over big M. So that works out to be, when we plug in the numbers, we get minus, minus 0.025 kilograms. And the velocity is 150 meters per second. So I have, this is little m times big V. That's the mass of the bullet times the velocity of the bullet. And then we're going to divide it by the mass of the gun, which was given to be 3 kilograms in the problem. Now if we look at this, we have kilograms divided by kilograms, so those will cancel. And I'm left with the units of meters per second, which is the right unit for a velocity, so that works out well. And then we can plug these numbers into our calculator, and we find that the velocity of the gun is negative 1.25 meters per second. And that negative sign here, this negative sign right there, that tells us that the gun is moving to the left, because we normally say that things moving to the right are positive and things moving to the left are negative. And so that is our answer. And I think because this is so complicated, I'm going to break this up and do the other examples in another video. So you'll have 2 short videos that you can watch, and hopefully you'll be able to go through them maybe 1 or 2 times and really understand how to work these examples.